Welcome. On YouTube, there have been a lot of people talking about the number of spotless days that the sun has had recently. Well, this is not unexpected because we're between solar cycle 24 and solar cycle 25, and so we're near solar minimum, I think just past it. So you'd expect a large number of spotless days, and that's what we're getting. There's nothing special about this. However, some people are trying to use these numbers to forecast that the next solar cycle will be low, or we're going to go into grand solar minimum. This video shows that such forecasts have no scientific basis. Here we have a plot of the number of sunspots as a function of time over the last 70 years. And there's always a lot of spotless days during solar minimum. Here are the 6 solar minima, and the range of spotless days in that time has been anything from just about 200 to over 1,000. Now the question that we basically have here is, does that number have any predictive capability as far as the next solar cycle is concerned? And I think you'll find that the answer is they don't. Here's a list of the statistics for the 25 solar cycles that we have on record. And you see that we only have spotless day numbers for solar cycle 10 and onwards. So we're going to compare the number of spotless days with the maximum of the various solar cycles. You'll notice that the most recent cycle has a very large number of spotless days. And that's what's led to the speculation that this might be heralding a grand solar minimum, or at least a very low cycle. And note that this cycle is still in progress according to this list, and therefore this number can only get larger. So how are we going to test this? Well, we're going to take the number of spotless days and compare it directly with the maximum of that particular cycle and see if there is any correlation. So this will be testing whether the cycle itself determines the number of spotless days. So let's first test whether the number of spotless days in a given cycle is associated with just the peak of the cycle itself. So here I've got the number of spotless days plotted on the y-axis and the maximum for that particular cycle on the x-axis. And you can see there's a sort of upper left to lower right correlation here, and that's exactly what we would expect. I've fitted a trend line to those data, and now you can see that with a dotted line. But how good is this correlation? Well, you can calculate something called the correlation coefficient, which is a measure of the spread of these particular points, and that came out to be minus 0.6. Now, the fact that it's minus says it's anti-correlated, which is what we'd expect, i.e. the more spotless days, the weaker the cycle, the less spotless days, the stronger the cycle. So that seems to fit. But how good is 0.6? Statistically, a correlation between minus 0.8 and plus 0.8 is considered statistically unreliable. So this is a bad correlation. You can draw no firm conclusions from it. If we want this to be a predictive cycle, you need to check the correlation between the number of spotless days that you're seeing and the next cycle. So let's test that. So how would we tackle that problem? Well, we take the same list that we had before, and instead of comparing the number of spotless days with the peak of the current cycle, we would compare the number of spotless days with the peak of the next cycle to see whether that number of spotless days had any predictive capability. So here's the equivalent plot that we had last time. And you can see that the correlation coefficient here is actually worse. It's minus 0.58. So this is not a good correlation either. Just to illustrate how unuseful these correlations are, let's say we had a spotless day number of 600 that we were trying to use to predict the next cycle. If we draw a box around that, that would say that we'd be predicting a solar cycle of somewhere between 120 and 250. So we're not getting the solar cycle amplitude within a factor of 2, and so that is basically useless. There is another way of looking at this. Rather than going from solar minimum to solar minimum, i.e. counting the number of spotless days in a given cycle, and then seeing whether that's correlated to the peak of that cycle or the peak of the next cycle, which is what we've just done, let's count the number of spotless days between two cycles and see whether that's correlated to the peak of the following cycle. So, i.e. if there's any predictive capability there. So I've rearranged the spotless days accordingly on the right here, And you can see that the number of spotless days between solar cycle 24 and 25 is not particularly outstanding compared with other cycles. So the prediction isn't quite so dire. So let's take a look at the results from that particular analysis and see if it's any better than the other two. Well, this is the plot when you look at that. Just to confuse you, I've reversed the axes. I've got the maximum spot count on the left and the number of spotless days along the x-axis. But you can see that the correlation doesn't look very much better. In fact, the correlation coefficient is slightly better at minus 0.62, but still is not a very good correlation. To give you some idea of how unreliable this would be, if you had a spotless day count of 750 like we have currently, we would be predicting a solar cycle anywhere between 80 and 230, which is basically useless. So what can we conclude from all of this? We have poor correlations for anything associated with the number of spotless days, either in association with the current cycle or predicting the next cycle. In other words, the number of spotless days does not predict anything reliably about the upcoming cycle. So if you see anyone on YouTube, or anywhere else for that matter, using the number of spotless days to predict anything about the upcoming cycle, please tell them that they're full of nonsense, and they have about as much credibility as this fortune teller. So until next time, stay safe and goodbye.